Now let's look at a practice problem where we're just practicing using our graphing calculator. Example 3. The age of graduate students in engineering programs throughout the U.S. is normally distributed with a mean of 24.5 and a standard deviation of 2.5. If a student is chosen at random, then let's calculate a bunch of probabilities. So first, let's define our random variable x as normally distributed with a mean of 24.5 and a variance of 2.5. So we got to put squared next to our standard deviation to make this fully correct. Part A, what is the probability that they are younger than 26 years old? So we're looking for the probability that some graduate student is less than 26. So let's go and open up our graphing calculator. We are going to go to second vars to get to our distribution window. Oh, let's try that again. I don't think I pressed the right keys. Second vars. We're going to select normal CDF. And for our lower bound, we're going to press some really large negative number. So mine by default already has 1 times 10 to the power of 99 or negative 1 times 10 to the power of 99. That's great. We're leaving it there. Our upper bound is 26. We're going to adjust our mean to be 24.5. And finally, our standard deviation is 2.5. Press paste. And we see here we get a value of 0.726 rounded to 3 sig figs. Part B, what proportion of students is older than 23.7 years? So now we're looking for the probability that our random variable x is greater than 23.7. Again, in our calculator, we're going to go second vars to get to the distribution menu, select normal CDF. This time, we have a lower bound of 23.7, and we're going to set our upper bound to be some really large number. So I'm going to set it to 1 times 10 to the power of 99. Our mean and standard deviation stay the same. Press enter, and we get a value of 0.26 if we round to 3 significant figures. Next question asks what percentage of students is between 22 and 28 years old. So here's our probability that we're looking for. Let's pretend the answer is not already there. And again, go to second, distribution, select normal CDF. Our lower bound this time is 22. Our upper bound this time is 28. The mean and standard deviation stay the same. And we get a value of 0.761 if we round to 3 significant figures. Finally, part D, what percentage of the ages fall within 1 standard deviation of the mean? I can use the empirical rule here, and I know that the answer is going to be 68%. Or you could be more precise and actually look for that probability and use your GDC to calculate it. Okay, but this is fine.